Hello everyone, welcome to BatNav's Energy Storage Sellers series. Today we're talking to EnerVenue about redefining energy storage with EnerVenue's metal hydrogen battery. Why do we need to redefine energy storage? Energy storage comes in many different forms because energy comes in many different forms. We have electrochemical systems, lithium ion, sodium sulfur, for example, mechanical systems of gravity and hydro, electrical systems utilizing capacitors, thermal systems, and also chemical systems. What's really interesting about the EnerVenue technology is they kind of sit between the electrochemical and the chemical. And it's going to be really interesting talking today with EnerVenue about their system and how it actually bridges those two divides and also provides a lot of benefits that other energy storage systems don't have. So joining us today is Chad Spring from EnerVenue. Chad is a senior manager for business development, and he's got a long history in the renewable energy and energy industries. And he'll tell us more about EnerVenue technology, the history of the company, and where it's going in the future.
Hey, thanks so much, Dave. Pleasure to be here, and thanks everybody for joining in and listening. So
I've been following EnerVenue for over a year now, and the technology is really interesting. It has a really nice niche, and when I say niche, I don't mean that in a small way. It has a lot of applications and benefits that it can bring, and I think a lot of people aren't aware of what it actually is and what it can do.
right, yeah, I mean, it's really changing the way that the industry is thinking about battery energy storage, so particularly stationary battery energy storage. So we'll get into some of the use cases and the differentiators with our metal hydrogen technology and how it compares and contrasts with lithium and other battery technologies out there.
Yeah, it's great. And the way that BatNav looks at energy storage is like there are so many different technologies, all with the potential to play a role in the energy transition. And we want to help companies like EnerVenue promote their products and make sure they find the right applications. And then the end users find the right applications as well. So let's get into it. So Chad, tell me about EnerVenue's backstory. It's pretty long from what we talked about before the webinar. So what's the history?
Yeah, so EnerVenue's technology, again, metal hydrogen chemistry, really goes back to the 1980s. So, we're not talking about a new chemistry here. We're talking about an evolution of a chemistry that's been around for decades. So back in the 1980s, NASA was deploying metal hydrogen batteries in their space applications. The reason they liked that was because of super long life, really, really durable in harsh environments, right? Outer space is a pretty harsh environment. And, all with very minimal to no maintenance. So it's hard to truck roll into outer space and perform maintenance. So the problem with that technology at the time, though, was its cost. So it had a lot of platinum material in the anode. It drove costs up to around $20,000 a kilowatt hour.
Wow.
So in 2017, as the stationary storage industry was really taking foothold, people just walked past this technology, didn't really give it the time of day because of that cost hurdle.
Yeah.
So Stanford University brought this technology in-house, kind of brushed it off, decided to really dive into that platinum piece. So they removed that platinum, replaced it with some other advanced alloys, and through testing got to the point where it was performing better, longer life, more durable than the original NASA chemistry, all with line of sight of being cost competitive with lithium. So when they reached that point, EnerVenue was then spun out of Stanford's Business Accelerator. That was in July 2020. So here we are just over 2 years later, and we're bringing our first commercialized product to market. And you can see some of the points mentioned here that touch on a lot of those differentiators with this chemistry. So super long life, able to operate multiple cycles per day, no fire risk. And we're going to dive into some of this as we go through this webinar.
Yeah. So that's a long history with obviously some pretty big institutions involved in the development. The thing that really caught my eye when I first came across EnerVenue was Professor Yi Kui's involvement. So
Right.
so the lithium ion side of batteries for stationary energy storage for EVs has taken center stage for the last decade or so. And I know that UQE has been one of the leaders in that area for development of those lithium cells, and also being in Stanford, in the San Francisco Bay Area type ecosystem. When I saw that he was involved in this in such a senior way, because I think he's the chairman, right, of EnerVenue.
He's on the board and acts as still kind of our chief technology advisor. So not involved in the day-to-day functions, but certainly pretty active.
So when I saw his name involved, I thought, okay, he understands energy storage, electrochemistry, everything around that. If he's got a big stake in this, then there's definitely something in it that is going to be competitive with lithium ion. So that's what really caught my eye. And so as I've learned more about it with you, I can definitely see that potential is still there.
Absolutely. Yeah.
Right. So Chad, you've obviously got a really good history in terms of the development of this system, but let's tell people a little bit more how the system works.
Yeah. So again, metal hydrogen or nickel hydrogen chemistry. And so if we look at this graphic here, we start on the right-hand side. And so we have our anode material, electroplated thin sheets. That's really the focus of Stanford's work and Professor Shui's work. So that's where the platinum was removed, the new material alloy, the new catalyst was applied. So we electroplate our anodes, we electroplate our cathodes. Those are then stacked with a separator in between, stacked in multiple layers, compressed in a clamshell. That is then inserted into our battery cell, which you see on the left, vessel, as we call it. So a little bit different terminology, right? We call it a battery vessel.
Yep.
And then a water electrolyte solution is added.
Okay.
Once that's added, it's capped and completely welded, sealed, shut. So it's fully self-contained, fully hermetically sealed vessel. Then during the charging process, the water electrolyte, basically, the water through electrolysis separates into hydrogen gas. Then during the battery discharge process, that hydrogen gas recombines back with water. So it's a full kind of self-contained cycle, catalytic process. So you're not seeing the degradation mechanisms that you see with lithium ion. Mm-hmm. So that speaks to our extremely long life with, we're going to touch on that here in an upcoming slide. But, a very safe, very robust reaction. Now, at full state of charge, yes, there is hydrogen gas, and we're going to get into the really exciting phenomenon of what happens to our battery at full state of charge when there is hydrogen gas in an external thermal runaway event. So there's nothing in the battery that's flammable. There's nothing that catches fire in this battery. If there's an external fire, we'll touch on the really compelling safety message here.
Yeah. Okay. So a couple of things, looking at this diagram on the left-hand side, that vessel you talk about looks a lot like a pressure vessel.
So that's why we use the term vessel. It's a low pressure vessel. Okay. So at full state of charge, it's around 800 to 900 PSI. Okay. If you think of a scuba tank, that's 3,000 or 4,000 PSI. Hydrogen storage tanks are much more than that. Yep. So from a safety perspective, 800-900 PSI is very safe.
Relatively low, yeah. But this is where it's really kind of interesting. What you're doing here is combining effectively hydrogen electrolysis, storage of hydrogen and energy in a chemical form, and then converting that chemical energy and the hydrogen back into electricity, all within a single system.
Right. Yeah. Think reversible fuel cell meets electrolysis.
Yeah. And that's what's really quite exciting, because you don't have the cost of storage. And if you can optimize those materials to minimize the losses, that's where it gets very exciting.
Right. Yeah. And we don't need a supply of, pure clean water. like some, electrolysis or hydrogen production facilities would need,
Yeah.
because it is all self-contained in the battery itself.
Yeah. Okay. Okay. And I don't know if we talk about this later in the webinar, or if we emphasize it much, but what about in terms of critical minerals that we use for this cathode and anode?
So, the general bulk of the materials here really consist of three things. There's, nickel, stainless steel, and water. And there's a few other elements sprinkled in there, right? The new catalyst, that alloy, which really is the special sauce, if you will. So, that really speaks to the fact that it's greater than 99% recyclable at end of life, because of the simplistic nature of the materials. So, at end of life, you cut it open, you disassemble the components, you put your nickel in your nickel bin, your stainless steel over here, and that's really the story. It's pretty simple.
And that sounds really like it's non-toxic materials as well.
Non-toxic, no lithium. It's very, very safe and user-friendly, if you will.
Yeah, that's a huge plus.
So with our battery cell or vessel, again, we've taken that, and that's really, the kind of the bulk of the work, the special sauce, that's the basic Lego building block of our system. We then take those on racks with our BMS, connected with cabling and bus bars, and you can see here our 20-foot EnerStation, as we call it. We're also engaging with other entities who have, a wealth of experience designing, fabricating, and deploying container systems themselves. So not only are we looking at doing this ourselves, but then also engaging with other third parties who have expertise in this containerization space to really make sure that we're able to offer a really attractive solution, for the market, whether that's a 20-foot container, a smaller 10-foot container. We're looking at different kind of go-to-market flavors, if you will.
Yeah, great. And the great thing about doing it in a 20-foot container is that the world's logistics is just set up for that.
Right. And, and this gets to the simplistic nature of the batteries. And I think in some of the upcoming slides, we're going to touch on all these differentiators, but no heating, no air conditioning, and no fire suppression is needed.
Yeah.
So it's literally this bank of batteries in an enclosure. You can stack these too high, even higher if your O&M, and maintenance plan would support that. But and also position these much more closely together at a project site. So you can increase your project density that way, increase it vertically, and it's a really, really simple battery storage system.
Definitely. That ability to minimize area, minimize footprint is a really important consideration, particularly in the commercial industrial space where your facility might be limited on what you can actually install. So it's a really good point. And also the temperature, like the no heating, no cooling, we'll talk a little bit about that later. But having a system that can go down to -30, Australia, we don't get those temperatures here, but the Northern Hemisphere does get those temperatures, and that's a real design consideration that you have to make. So huge advantage. Great.
And I will say, for anybody out there who wants to engage, talk about this system, talk about how this works in a project, reach out. I'm happy to talk, get an NDA set up, and we can certainly dive into the meat and potatoes here.
Yeah, great. There's a lot to it. All right, so what do we got next? So track record. So you've got a great technology. You've obviously got track record in terms of the research and development. You've got a great system. And so what's happening in terms of building a production facility and a team and everything?
Yeah, so early on, we talked about the NASA days, Stanford days, and then EnerVenue was spun out. So if we pick up there, and we start from EnerVenue's founding, which really was July of 2020. And so you can see in the slide here, that's the core team from day one. And I think there's even maybe an Uber driver and a DoorDash driver in there too, just to make it seem like more employees. But that's the early days. So fast forward another year, and July 2021. So we've grown at that point, over a year ago, over 100 employees. And you can see down at the bottom there, we're starting to put together kind of our first strings of our batteries and testing the way that the strings respond. And then fast forward again another year to June 2022. So just a couple months ago, you can see our new facility there in Fremont, California, behind all of us. So that's a new facility we're transitioning into now. That's where our production takes place. That's where all of our office staff will be transitioning from our original building into this new, much, much larger facility here before the end of the year. So, and then you can see, some of our customer deployable EnerStations down there, which we are delivering those here throughout the rest of the year with some of our really key customer relationships that we have, where our customers are bringing them into small pilot projects, bringing them into, their test labs, really to, kind of put it through its paces and validate the messaging. So we then fast forward to June 2022. And so you can see our group there with our new facility in the background, and then our customer deployable units there in the bottom. So we are deploying those to our key customer strategic accounts here throughout the rest of this year for, demos, test projects, pilot projects, and so forth. So yeah, very exciting.
Great.
So we've got some great folks, great leadership on board. So Jörg Heinemann is our CEO, former executive at SunPower, and then of course, Professor Yishui from Stanford, Majid Keshavarz, our CTO, been around all battery chemistries, the vast majority of his career. Frank Bloom in charge of ramping and scaling us up quickly. Betsy, our CFO, comes from 8-Minute, First Solar, and Iron Mountain. And then Randy Selesky, our Chief Revenue Officer, former Greensmith executive, and then Greensmith went through the acquisition by Wärtsilä, and then also former VP at Rockwell Automation. So great team, great people. Yeah, a lot of fun.
Yeah, great. So Chad, you've got a really impressive leadership team. The team is growing very rapidly, which must have its own challenges. But let's talk about positioning the EnerVenue technology. Where does the system really excel?
Yeah, so this is the fun stuff that I love talking about. So if we look at the slide, there's a lot here, but the gray areas are really highlighting the challenges seen with today's lithium ion technology. The orange areas are EnerVenue's differentiation to those risks. So if we start on the top left, so fire and explosion risk with lithium batteries, not a surprise. You hear in the industry of these fire events that happen all too frequently. With our system, again, I mentioned earlier, no thermal runaway risk, which means no fire suppression systems are needed. And so we've completed our UL 9540A testing that has passed with flying colors with, again, no fires, no sparking, no chance of any fires there.
Okay.
And then moving on from an OpEx standpoint, our degradation is not nearly what you see with lithium ion. So you're never needing to come in and augment with additional battery horsepower over the entire 30-year life of the project.
Okay, so that's you're talking about degradation there when you're seeing augmentation, as in you're adding additional capacity, power, or energy to the system because you've got degradation over time.
We don't have degradation, but lithium ion. You don't have degradation. Yeah. Right. So that's typically, lithium ion is going to typically degrade around 2% per year. And it kind of depends on how frequently you're cycling that. With ours, it's around, depending how many cycles, anywhere from 0.2 to 0.4% per year. Yeah. So an order of magnitude less. Yeah. So, and then if we look at the way you can operate this, so from a C rate standpoint, C/2 is our peak C rate in our system today. We will have a power battery application coming out later in 2024 that will be up to around 4 or 5 C. So a very, very fast charge and discharge.
Yes.
But today's system's a 2-hour out to about a 10 or 12-hour system. And you can operate, varying C rates depending on your use case of the day.
Yeah, definitely. Yeah, if you can get those C rates up around like the single digit numbers, you can definitely do a lot of those ancillary services, which are high discharge, puts you in sort of the short duration grid services type market.
Right. And then also looking at our life cycle. So over 30 years, 30,000 cycles, which equates to operating at 3 cycles per day for 30 years. So that means back to back cycling, no need for any resting period. You can really, kind of put the pedal to the metal, operate it hard. And it's, for all intents and purposes, it's a unlimited life cycle battery. You're never going to get to 30,000 cycles. And again, all without augmentation.
Yeah. The overcharge and discharge, the susceptibility to that's often one of the downfalls of the smaller cell type of systems that don't have that ability to withstand overcharge and discharge. That's where you can start to get early degradation of cells and then sort of more cascading failures. So the ability to tolerate those kinds of conditions is also really beneficial.
Right. Yeah. I mean, our battery is very comfortable from 0% all the way to 100% state of charge. It doesn't require a certain resting state of charge.
Yeah.
It ships at 0%. So that allows you a lot of flexibility there too. So,
great.
And then, really wide operating temperature range, -30 to 50 C. And that's without heating or air conditioning. Yeah. So you combine no fire suppression, no heating, no air conditioning. So your balance of system is very, very minimal.
Yeah.
Very low aux loads. So it all kind of plays into the total cost of ownership puzzle.
Yeah, definitely. And then, we're not even going to talk about this, but there's so many benefits in terms of being able to manufacture a system like this, and quality control is a lot easier because, lithium ion, and I love lithium ion. It's great technology, but it does require a lot of process control, a lot of control over your raw materials and all the steps. But this seems a lot more tolerant to just the reality that manufacturing gets messy sometimes.
Right. Yeah, it's a very easy to manufacture battery. It's very simple. And we had a customer, just as an aside, we had a customer in our facility yesterday. And as they saw our manufacturing process, they looked around and said, "Well, where's the rest of it?" We said, "No, this is it. It's very simple. It's very basic."
Yeah, that's a huge plus, definitely. Okay, so we talked a little bit about safety. Now, as I said before, you got pressure and hydrogen. That's usually a bad combination, but you've done the abuse testing, and tell us about what the results were.
Yeah, so we're going to touch on 2 different things here. We're going to touch on a fully charged battery in a puncture test. We're then going to touch on a fully charged battery in a thermal runaway test. So in this example, in the battery or the nail penetration test, you can see on the left, you take a lithium pouch, you puncture it with a nail, it immediately combusts.
Mm-hmm.
On the right, we have our battery vessel. And we punctured a third-party test lab, I should clarify, punctured a nail through it. Now, first of all, it's a stainless steel vessel. It is not easy to puncture a nail through a stainless steel vessel. Mm-hmm. So they actually had to drill partway through and then puncture. Mm-hmm. No fire was observed. No sparking was observed. The small amount of hydrogen that is in there, yes, that does escape through that puncture. But of course, hydrogen, as soon as it hits atmosphere, is so light, it immediately dissipates. There is not enough concentration of hydrogen to cause any kind of flammable response.
Okay.
Now, if you think about NFPA guidelines, NFPA 855, in the event of a hydrogen, leak or dissipation of some sort, the requirement is that needs to be immediately vented with ambient air and released to atmosphere. So, so hence our systems that we showed earlier, our 20-foot containers, those do have, hydrogen detection, ventilation, all that kind of stuff to comply with the NFPA requirements. And,
Yeah,
and additionally, I mean, lithium batteries also outgas hydrogen in a thermal runaway event as well. So it's, we're not doing anything new or different here in our safety precautions.
definitely, Chad. The venting of the hydrogen, a lot of people would be quite concerned about that. But it really does depend on the amount of hydrogen that is released and its mixture with other airs to be able to reduce it down to a concentration where it won't it won't cause combustion. So all of that stuff's pretty well known in the gas industry. So if you can prove that and comply with the standards, that's very reassuring, particularly for me, because I have worked in the gas industry.
So looking then at our thermal testing, so we did a whole slew of thermal tests through, again, third-party labs, where we did the thermal runaway test, where we wrap it in the heating coils, the overcharge test, which basically just builds up the temperature inside the battery. And then we did what I think is really the most interesting test here, where we literally put our battery cells in a bonfire. And in all three of these tests that I mentioned, the same result was the outcome. So you can see on the left here, the battery, sitting in the fire. Over time, heats up.
So that's wood there, right? You've got it stacked in amongst wood.
That's right. So the battery is tucked in the middle there of the wood. And so you can see kind of the wood on either side of the battery and then the wood across the top. So then in the right picture there, you can see the result. And so you can kind of see the nozzling effect that occurs there, where steam is then being vented out of our pressure relief valve.
Yeah, I can see that little jet, the jet of water spraying out there.
Exactly. So there's a really interesting phenomenon. If you want to dive into it, let's get an NDA put in place. I'd be happy to really dive into the details, but the punchline here is that no hydrogen is released, and instead that hydrogen is converted back into water, which then generates steam as the battery continues to heat up.
Yeah, it'd be interesting to see, like, from a materials engineering point of view, it's probably, that hydrogen dissolves back into the water at those temperatures and then just comes out with the water.
And it actually is extinguishing the fire.
Yeah.
In front.
Yeah. And you haven't got like a organic based electrolyte like lithium ion that is flammable, so it just vents and self-extinguishing.
Right.
Nice. Right. Another plus. So commercial and industrial market, you're focusing on that?
So we're focusing on the commercial and industrial and grid scale. And so the C&I market, this battery can really be used, I like to call it a Swiss Army knife of battery storage. So, reducing a facility's costs through demand charge reduction, that's a huge ROI that these facilities are really focused on. Improving the resiliency, right? So power goes down and you're in a major manufacturing or stamping type facility, and power goes out, and that's a major problem. Improving the sustainability, right? So tapping into the renewables, on-site wind, on-site solar generation, being able to capture and energy shift some of those renewables is super helpful. And then also earn revenue. So some of the grid services, so being able to kind of perform functions outwardly facing rather than internal to the facility itself.
And what I'm seeing now with BatNav's clients is that as the prices of energy are increasing, so electricity from the grid or diesel or whatever other conventional sources of electricity, the actual viability of an energy storage system combined with solar or wind is becoming closer and closer to competitive.
Right. Yeah, absolutely. I mean, and when you think about being able to cycle our batteries in particular multiple times per day, that long life, no augmentation, you can really start to monetize it in a really different, compelling way.
So what about the grid scale or grid utilities?
Yeah. So again, because of the uniqueness here, we really can touch on kind of all the different nodes around the electric grid. So obviously pairing with renewables, obviously standalone energy storage, and then also the congestion relief when it comes to T&D deferral, and so supporting that transmission side. We just touched on the C&I loads. There's a really interesting use case for residential that, that's a very different go-to-market strategy. But having our batteries, because of that no fire safety message, being able to put our batteries in net zero footprint impact areas of a house. So in the attics, in the crawl spaces, batteries are in there, you set it, you forget it, and now you've got integrated energy into your building. And so that's a whole new kind of market that we're really excited about.
That's a really good point, because I'm looking at a battery for my home at the moment and trying to work out, really the only option is a lithium-ion battery. I'm aware of the pros and cons, and from a safety perspective, I'm trying to work out where I'm going to put it. But if I had a system that I could put in my ceiling cavity, that would be one place that I wouldn't even notice.
Right. Yeah. I mean, we think of it as, you have your large, regional or national home builders. And, as they're building their subdivisions or these houses, you've got a checklist. You want granite countertops? Check. You want French doors? Check. You want EnerVenue battery storage? Check.
Nice. Yeah, there's a lot of work in Australia at the moment around that. Some residential developments really testing out those ideas. Okay, there's a lot of impressive stuff there, Chad. But what's the future look like for EnerVenue? Tell us what you're going to be in the next 5 years.
The future is exciting. The market is growing like crazy. The global energy storage market, we're just getting started, which is, insane to think about. Where we are as a company, so this year we're at 10 megawatt hours in our manufacturing capacity, and that's a very manual build process. Even in a manual build, we're getting greater than 90% yield out of our batteries. Phenomenal. Next year, we'll be at 100 megawatt hours, and that's through our high-speed automated line, and that's in Fremont, California. So we're bringing in this equipment now, getting that up and running. So January 2023, we'll be at that much higher run rate. And so that allows us to start feeding kind of the smaller megawatt hour scale projects with a lot of the customers that we've been engaging. In parallel to all that, we will be announcing very soon, in the next 2 to 3 or 4 weeks, our Gigafactory. So our first Gigafactory will be here in the US. Think central US, most likely, but more to come on that. And that'll be at 1,000 megawatt hours. And then in 2025, we've got 5,000 megawatt hours, and continuing to grow that as we go. So this shows our 100 megawatt hour production line, the equipment there that we're in the process of getting installed. It's a couple month process to get that installed and vetted and everything. But our automation suppliers have been great. They've been working on this literally for the last year in their facilities. So we're really hoping, it's a drop and play kind of a scenario with very little debugging that's needed. And then we take that 100 megawatt hour line, and then we duplicate that in our Gigafactory. And so here you can see, each of these little cells down below, you can see 16 of those. Those are each, kind of our singular automated line. And we basically copy paste that 100 megawatt hour line in our Gigafactory.
That's great. Very flexible. You can just keep adding modules as your demand grows.
Right. Exactly.
Nice. And the location announcement coming soon.
Coming soon. Yeah, we're hoping to get things signed on the dotted line before the end of this month. So we like to say Midwest, Great Lakes region here in the US. Now there is then a global expansion plan. Can certainly talk about that. We have a great partnership in one of our Series A investors, Schlumberger, the large oil and gas conglomerate. And so we're working closely with them. for deploying kind of worldwide. And there's more to come on that as we work through those details. But from a factory standpoint and production standpoint, it's easy to replicate. So we'll have our manufacturing facilities in various regions around the world supporting those local industry demands.
Great. Very exciting. Very exciting.
Yeah.
So your company values, EnerVenue, like purpose and mission. Tell us how you sort of explain that to your customers.
Yeah. So our company values, every day, everybody comes to work and they see the purpose and the mission, right? We're all marching in the same direction. So we're here to accelerate the clean energy revolution, right? That's why we're all here. Greenhouse gases, temperatures are increasing, weather is getting worse around the globe. So it is a all hands on deck type approach. And we want to be a key part of that. So our mission, in order to achieve that purpose, our mission is to become the top global supplier of energy storage for homes, businesses, and energy storage power plants by 2035. And we think we can do it. It's a rocket ship growth curve, as Jorg, our CEO, always shows in our company meetings. Our business plan is a rocket ship. So
great.
Buckle up.
Yeah, definitely the potential is there. Chad, thank you very much for spending the time today. It's been a pleasure talking to you again. I'll let you go now so you can start doing some training for those ultra marathons you love to do. It's been fantastic talking to you more in depth about your system and EnerVenue as a company. So really appreciate your time and sharing that information. I'm sure customers can get in touch with you if they want some more technical information or understand when they can actually get some orders in. And I really appreciate your time.
Thanks, Dave. Appreciate you having me on. Really like what you and BatNav are doing. Great discussion today. Yeah, I enjoyed it.
Thanks very much, Chad, and keep me posted on the progress of EnerVenue. I'm really interested to see where it goes.
Yeah, definitely. Thanks.
Thanks.